up to this point, I've taken it pretty easy on you. All of the equations that we've gone through so far, we haven't had any rows that are all zeros, and we haven't had any solutions that have infinitely many solutions. So we've only ever had an inconsistent system where we have no solution, or we had one unique solution. So let's talk about what happens when that is not the case. So we have here solution sets and free variables. So again, we're focusing now on a consistent system, meaning yes, there is a solution, but we have infinitely many solutions. So let's talk about what that means. What I have here is a matrix that's already in echelon form, not reduced row echelon form, because obviously I have some values here that are not zeros, but it's in echelon form, and that's okay. Sometimes this is as far as you can get. Now keep in mind that this translates into the equations that I have written in green here. The question is this a consistent system? And what are the solutions? Well, 0 equals 0 is okay because that's true. So don't freak out about that. The only time we have an issue here is if I have 0 equals, say, 8. Well, then we'd have an issue. Since we don't, this is a consistent system. What am I going to do to talk about the solution? Well, x1, notice what I've done is I've taken this equation and essentially I've just isolated the x1. So x1 can only be found by using x3. x2, if I rewrite the system, can also be found using x3. Now, why is this important? Because x3 is not defined. x3 is called a free variable. And essentially what that means is free variables can be any value that we want them to be. We can essentially choose a value for x3. And once I choose a value for x3, then I'm going to be able to determine the value of the other variables that we are calling basic variables. So let's take a look. If x3 was 2, then I would say x1 is 5 times 2 plus 1, which is 10 plus 1, which is 11. And x2 would be 4 minus x3, or 4 minus 2, which is 2. So one solution to my system is 11, 2, 2. x1, x2, x3. Let's try another one. If x3 were negative 6, then x1 would be 5 times negative 6 plus 1, which is negative 30 plus 1, which is negative 29. x2 would be 4 minus negative 6, which of course would be 4 plus 6, which is 10, which means another solution to my system is negative 29, 10, negative 6. So essentially what I'm saying is, yes, there are many solutions to this. Here are 2 of them that I have computed myself, but there are infinitely many because I can choose x3 to be anything I want because it is a free variable. Here's a great practice for us to do together. This one is saying find the general solution to the system. Quite often that is what the instructions will be. And essentially what that means is if you end up with a free variable, we're going to write it in the same format that we did in the last one. We're going to isolate the basic variables and write them in terms of the free variable or variables. So let's go ahead and work through this one together. Again, step number 1 is, of course, to write an augmented matrix. And you might be asking yourself, is my instructor, me, am I going to make you continue to write the row operations? Can't I just do all of the math in my head and Miss Brame, you can just figure out the solution? And the answer is eventually, but for now, I want to see each of your row operations. So show me everything for now, because we're just getting started. So here is my augmented matrix. Again, I'm going to follow the same steps that I did before. And those steps are, I want a 1 in my pivot position to the top left. And again, if you need to, do some highlighting or whatever, this is a pivot. So that's going to be a pivot, and we're going to keep that a pivot, which means I need zeros below that. So how am I going to get a 0 below that? Well, I'm going to have to take 2 times row 1 plus row 2 to be my new row 2. And on the same step, just because I want it all to fit on one slide, I'm going to take negative 3 times row 1 plus row 3 to be my new row 3. So essentially what I'm doing is all in one step, I'm going to get zeros below the 1. So my new row 2 is to take 2 times 1 plus negative 2. 2 times negative 2 is negative 4 plus 4. 2 times negative 1 is negative 2 plus 5. 2 times 3 is 6 plus negative 5. And then 2 times 0 is 0 plus 3. And row 3 would be negative 3 times 1 plus 3. Negative 3 times negative 2 is 6 plus negative 6 is 0. Look at my fat fingers down here again. Negative 3 times negative 1 is positive 3 plus 6 is negative 3. And then negative 3 times 3 is negative 9 plus 8 is negative 1. And then that gives me a 2. So that's step 1 is to get these, or sorry, I guess step 2, technically, get zeros below the 1. And then we're going to repeat. So I want you to notice we don't have anything in the column 2 except for the negative 2 above it, which we don't care about because that's not a pivot. So basically what we're saying is column 2 doesn't have a pivot. For 3, I'm going to try to make this into a 1. But essentially, let's just take a look at what's going on here. What would happen if instead of just following the algorithm blindly, I said, hey, let's take row 2 and add it to row 3 and make it my new, say, row 2. I don't care if you make it row 2 or row 3, but my first row would remain exactly what I have. And my third row I've decided is going to remain. But my second row is going to be row 2 plus row 3. So that gives me 0 here, 0 here, 0 here, 0 here, and 5. So hopefully you're finding that this is an issue. And again, I could have made that row 3 and it wouldn't have mattered. It would have been exactly the same thing. It really wouldn't matter. What does matter is that I have this situation here. 0 plus 0 plus 0x1, 0x2, 0x3, 0x4 is equal to 5. So essentially I have 0 is equal to 5, which is of course not true. So I get to stop because this is an inconsistent system. Not true. And it doesn't matter, again, if I would have made that into R3, I'm still going to have the exact same row and I'm still going to have an inconsistent system. Here's one for you to try on your own. Again, we are looking for a general solution, which means if it's inconsistent, you can just say inconsistent. If it's consistent with one solution, give me that solution. If it's consistent with infinitely many solutions, that's what we really call that general solution, which means if a variable is free, we will say that it is free. If a variable has a value, we will name that value. If it's neither of those, then we're going to write it as a relationship to the variables that are free. So go ahead and press pause and try this question. When you're done, press play to see how you did. The first thing I would do, as always, is to try to turn any values below my pivot, and obviously this is a pivot. Anything below that needs to be a 0. How do I make it a 0? Well, I can take negative 3 times row 1 plus row 2 to be my new row 2. That was a really bad arrow, but you get the idea. So this is still 1, 3, 4, 7. Row 2 is now 0 and 0 and negative 5 and negative 15. As you can see, what happened here, this guy is still a pivot. Nothing is going on in column 2. Column 2, my value went away, which means my next pivot is going to occur right here. This is important because there's nothing happening here, and that's going to help us when we're determining values that are free and values that are not. I'm going to go ahead and finish before I write the general solution, and by finish I mean I'm going to take negative 1/5 of row 3 to get my new row 3, because remember I want this guy to be a 1. So what do I have? 1, 3, 4, 7, and then I'm taking negative 1/5, which gives me 0, 0, 1, 3. So let's keep in mind that my matrix means x1 plus 3x2 plus 4x3 is equal to 7, and 1x3, or just x3, is equal to 3. This is not my general solution. My general solution will be written with a bracket. We'll give a value for x1 and for x2 and for x3, and if one of them is free, then we'll just say that it's free. Again, how do I know which one is free? That all has to do with pivots. So as I can see here, let me change colors. The 1 is a pivot, so it's not free. Column 3 is a pivot, so it's not free. This guy didn't have a pivot, that's free. So x2 is free. That's how I know which one is free. And that's going to help me when I get to this guy, because sometimes it's unclear which variable I'm supposed to isolate. So before I get to that guy, obviously I'm going to do the easy one. x3 is equal to 3 because that's what we found in the solution. Now, for x1, again, now that I've written it like this, it's clear that I have to isolate x1. So now I have x1 plus 3x2, and again, that's how it's very helpful to know which one is free, so that I didn't try to isolate x2, plus 4 times 3 equals 7. So I have x1 plus 3x2 plus 12 is equal to 7. And I'm trying to get x1 all by itself, because I want x1 equal to in order for this to be a proper general solution. So I'm going to go ahead and subtract 12 from each side, and yes, I'm going to do this in separate steps just so we're very clear. Subtract 12 from each side, and then I'm going to subtract 3x squared from each, or sorry, look at me writing squares instead of 2. You guys should correct me when I do something stupid like that. So I have negative 5 minus 3x2. That should be my final solution. Negative 5 minus 3x2 is x1, x2 is free, x3 is 3. No need to find any specific solutions. That's why it specifies find the general solution. The general solution basically gives us a value for each variable or tells us that that variable is free.